Hey, 12, back again. Ooh, look back here. I'm little, I'm big. Yeah, wasting time now. Intersection of lines today. If I have two straight lines that are not parallel, that means their gradients are not equal. Right? Two straight lines, non-equal, different gradients. That means they are going to intersect. They're going to cross over in exactly one point. Now remember, any line is made up of an infinite number of points, or we could say there are an infinite number of points, an infinite number of coordinates that satisfy that equation. If I substitute in, left-hand side equals right-hand side. Okay, infinite number of points for any line. However, when I have two lines that intersect, right, the points on one line won't necessarily satisfy the other equation. That will only happen if I happen to have the single unitary point where those two lines intersect. Right, that's what we're trying to find today. I want to find what pair of coordinates satisfy both equations. Right, that's equivalent to the coordinates of the point where these two lines intersect. We can do that by graphing these things, and we're going to do it visually today. Right? We graph these two equations and we want to see where they cross over. So first of all, y equals x plus 2. Y-intercept of 2, gradient of 1, cross 1, up 1. Yeah, cross 1, up 1, and so on. Cross 1, up 1. I have a feeling I want to go a little bit further here. Cross 1, up 1. Right, and I could go back 1, down 1 if we like. Now, if I can neatly join these up, and I'm stressing that a bit because we're doing this visually, I rely on having drawn them neatly to be able to read them off accurately. So, pencil and ruler. If it's not good, rub it out, do it again. I can tell you, this is not the first time I made this video. I've already rubbed it out and done it again. Now, let's have a look at the second one. 2x minus 3. Gradient, the y-intercept is minus 3, so we start down here. Now go across 1, up 2. Cross 1, up 2. Cross 1, up 2, cross 1, up 2, and across 1, up 2. You can see it's getting closer. You can see why I extended that line up a little bit further, and now I see that they appear to have crossed over. This is not perhaps a brilliant example, because without the graph underneath, it's a little bit tricky. It's a little bit tricky to read off the coordinates at that intersection, but certainly it would look to me to be at x equals 5, y equals, we went across 1, up 2 here. That look, I'm pretty confident that that occurs at 5 and 7. If I were to substitute 5, 7 into this equation, I'm going to find left-hand side equals right-hand side. If I substitute into this equation, I find it again to be true. So there we go. That's how it's done. Find the coordinates of the intersection. It is at 5, 7, or it certainly appears to be. The neater we draw that, the more reliable it is, the more confidence we can have in giving that answer. Right, the solution to the simultaneous equations, right, the solution is exactly what we've just done there. 5, 7. Now sometimes we say x equals 5, y equals 7. But you know what? Oops. Don't do that. You know what? That's what this means. X equals 5, y equals 7. So we have actually entered 3 different questions there, all at the same time. That's the intersection of points. Right, make sure you catch up on any work that you haven't finished yet. Make sure that you catch it up. It is vitally important. This is very important. Right, make sure you catch that up. Check out this video here. We will spend some time in class going through this, and that will be Tuesday, simultaneous equations on Thursday. Okay, good luck.